Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this complete CCNA course. I'll include the link in the description. Also remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. In this lecture, you'll learn about our second option for inter-VLAN routing, which is router on a stick. And out of the three options, this is probably the one that you're most likely to get tested on the CCNA exam. So make sure you understand this and know how to do the configuration for it. Okay, so this is how it's going to look. We've got our switch here in the middle, and we've got our access ports configured on here for our engineering VLAN PCs and our sales PCs. In the previous option, we were using a separate physical interface on the router for each of our different VLANs. But a problem with that is you're going to run out of interfaces. So a way that we can resolve that is by using virtual sub-interfaces on the router, which are all on the same underlying physical interface. So that's what we're doing here. So going down from the router to the switch, there's actually just one physical interface here and one physical cable. The physical interface we're using on the router is interface fast0/1 here. So we configure that interface with no IP address, but we do a no shutdown on it to bring the interface up. Then we add the interface fast0/1.10. Just by putting in the command interface fast0/1.10, that will create the virtual sub-interface for us. We then specify that sub-interface is going to be in VLAN 10, and we give it the IP address 10.10.10.1. That is going to act as the default gateway address for our engineering PCs. We then also create a sub-interface for the sales VLAN. We're going to use interface fast0/1.20 for this example. With your sub-interfaces, it's the main physical interface name and then a dot and then the sub-interface number. And you don't have to number them sequentially like 1, .2, .3 and so on. So that's why I've used .10 and .20 here, because it's more logical. It ties up with the actual VLAN number. So an interface fast0/1.20, I specify that is for VLAN 20 and give it IP address 10.10.20.1. Now what's going to happen is my engineering PCs, when they want to send traffic to another IP subnet, I've already configured them with their default gateway address of 10.10.10.1. So if an engineering PC wants to send traffic to a different subnet, it will send out an ARP request for the MAC address of its default gateway. The switch will forward that to everything that is in the engineering VLAN, all the other engineering PCs, and it will also get sent up the fast0/1 interface going towards the router, and we've configured that interface on the switch as a trunk port. So when the switch sends it up to the router, it will tag it with VLAN 10. So it will hit the VLAN 10 sub-interface. The router can then reply back to the ARP request, and we're going to have routing going through there. So whenever the switch sends traffic up to the router, because that fast Ethernet 0/1 port is configured as a trunk, it will tag it with the .1Q tag. When it reaches the router, it looks at the .1Q tag, and that's how it knows which sub-interface this traffic is for. So the configuration to do this on the router, interface fast Ethernet 0/1. So I'm using a different interface number here, 0/1 for this configuration. That is the physical interface that is connected to the switch. I don't need an IP address on here, so I say no IP address, but I do need to bring it up, so I say no shutdown. I then create my first sub-interface with the command interface fast Ethernet 0/1.10. Because it starts fast Ethernet 0/1, it knows it's a sub-interface attached to this physical interface, and then .10 is the sub-interface number. encapsulation.1q10. By saying that, whenever any traffic comes up and hits the interface, which has got a .1q tag on there, if it's .1q tag 10, the router knows it is for this sub-interface. Whenever I send traffic in the other direction, sending it down to the switch, when it comes from this sub-interface, I will tag it again with .1q tag 10. I put my IP address on here, IP address 10.10.10.1 with a /24 mask. So that is my engineering VLAN subinterface configured. I do exactly the same config for my sales VLAN subinterface. So interface fast Ethernet 0/1.20, encapsulation.1q20 for the sales VLAN, IP address 10.10.20.1, 255.255.255.0. If I just go back a slide, you see we've got the connection to the wide area network again, available out interface fast Ethernet 0/2 with IP address 203.0.113.1. The next hop address in our example is 203.0.113.2. I want my PCs on the inside to be able to get outside the local area network as well, so that's why I'm configuring a static default route here. So the command is IP route 0.0.0.0, 0.0.0.0, the next hop address of 203.0.113.2. Okay, that's the entire router configuration. I need to put a matching configuration on the other side of the link on the switch. So on the switch, I say interface fast Ethernet 0/1, switch port mode trunk. So now whenever the switch sends any traffic up to the router, it will tag it with the .1q tag, so then it will hit the correct subinterface on the router. Some considerations here. You don't need a separate physical interface for every VLAN. So this is better than option 1 where we did that. You're less likely to run out of interfaces here. However, traffic being routed within the campus still has to go up and down a physical Ethernet cable to the router. And here you've got traffic for multiple VLANs all using the same cable. So there's more contention for bandwidth than when we were using separate interfaces in option 1. Okay, so that's the theory. Next up, let's configure this in the lab. We've got the same topology as in the last lecture when we did option 1. The only difference is we've only got one link going between the switch and the router here. Again, I've already configured all of the layer 2 configuration. So I've configured my trunking going through from switch 1 to switch 3, and I've configured my access ports and put the correct PC into the correct VLAN. So if I go on to my Eng1 PC, you'll be able to see it can ping other Eng PCs. So I can ping 10.10.10.11, the other PC on the same switch, and ping 10.10.10.12 over on switch 3. But if I try to ping a sales PC, this isn't going to work because I haven't configured the routing yet. So let's do that now. I'll configure the router first. So again, I need to open this in Packet Tracer. I'll open up R1, go to the command line, and go to global configuration. So the switch is attached to interface fast 0/0 here. No IP address is the default anyway, and I need to do a no shutdown to bring the physical interface up. Then I'll create my first subinterface. So interface fast 0/0.10, and then I will say encapsulation.1q for VLAN 10, the IP address 10.10.10.1 with a /24 subnet mask. I don't need to do a no shut here because it's a virtual interface. As long as the underlying physical interface is up, this will be up too. I need to configure my subinterface for the sales VLAN as well. So that's also an interface fast 0/0, and it's going to be .20. I'll say encapsulation.1q20 and IP address 10.10.20.1, 255.255.255.0. I'm also going to do my default static route to allow them to route out to the WAN as well. So IP route O.O.O.O.O, the next hop was 203.0.113.2. Okay, that is my router config done. Next up, I need to configure a matching configuration on the other side of the link. So that was on switch 2. On switch 2 at global config, the router is connected to interface fast 0/1 here. And I need to say switch port trunk encapsulation is .1Q and switch port mode trunk. Okay, that's all the configuration done. All I need to do now is test it. So I'll go back onto engineering 1 and let's try pinging the sales PC that's on the same switch here. So that was 10.10.20.12, and it will probably miss a few pings while the interfaces and everything's coming up and it's doing the ARP. So let's just wait for this. In real world, it's probably going to be successful a bit quicker. This is because I'm using packet tracer here. So looks like maybe all the pings are going to fail. Let's try it again, and there we go. The ping is working now. Let's try pinging 10.10.20.10 over on the switch on the other side of the network. And this should hopefully work fine too. Yeah, there we go. That's all good. So that was the theory and configuration and verification for router on a stick. See you in the next lecture for the last option, which is using a layer 3 switch. Thanks for watching. If you'd like to get the complete course ad-free right now, then you can enroll in my CCNA Gold Bootcamp by clicking the link above my head or in the description. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.